to your favorite artist electronics experiments. Do you like my bomb I'm making here? It's looking for sure. It's looking like a bomb, but it's full of aluminum and heatsink and a single transistor here on the back. A lot of cardboards for leveling, not to rock like that. You know, is staying. It is moving like a little bit, but let me do it like a tiny bit is moving, but is not doing it like that. So I'm having this here that is catching this, and this is flipping like this. I wanted to show you that I have another piece of cardboard here and here, distancers, to have a little bit of space because of these motherfucker pins that I'm having here and here that are getting out. If we are looking like this, you see they are getting out from there, and I imagine the these distancers to make them like that. So that's how he's looking underneath, how he's making the contact with the pins of the transistors there, and here with the collector with this wire. So this is the emitter and this is the base wire, as you can see. Let me put it back here like that. Okay, it's very flimsy, it's very cardboard-y. it's full of cardboard, and I really don't recommend it. I really don't make stuff like this from cardboard, especially for this kind of power and this kind of heat. But I do play it safe in the sense that I'm not letting it run to too much heat. So I'm kind of careful, but I have to remember this in the future, not to run it too hot. The transistor that is here, and these two resistors, especially this smaller one, in the maximum. So now I made some modifications from the original setup that I had from my American friend, and I had to make these modifications to fit my needs, and in the same time to adapt to what I'm having here, this kind of radiator, this kind of transistor that I'm using, power transistor, which is not that powerful. Yeah, I had a lot of problems. I actually thought at some point to redesign everything. I started to make some modifications here on the paper only. I redesigned the entire circuit. I thought, here these two potentiometers are these ones that you are seeing here. I already started it, but then I said I will continue the one that I'm having with the setup that I'm having, because it is very extremely hackable the way I constructed initially. So what I was going into this circuit that I'm having here and this arrangement or this design, it was not that hackable. It was a little bit too fixed. Too screwed in places, and not that much liberty that this what I'm having here is offering me. This was too already sized, and I couldn't get out of those sizes if I wanted to add or to cut from it. It's just like that, pack, written in the stone almost. But while I was thinking on this circuit and how to make it better than it was before, I got over a couple of issues that the other circuit, the other board before this one was having issues, like the naming here, collector, base, and emitter, which I already changed them here, and I put larger pads there and there, especially for collector and emitter. For the base doesn't matter, but here they were like the base initially, this pad size for the emitter and the collector, and they were starting to get out from the cardboard because they are very thick wires, as you can see, and they were dragging a lot. I was moving them a lot, and the pad that is like this in the cardboard was ripping out, pulling out the cardboard, and the cardboard couldn't hold it securely anymore. So I made a larger surface, a little bit larger than it was before, and I suppose now it's better. This thing that you are seeing here is for different resistor sizes. So for this size, actually this cardboard was a little bit longer, and this diagonal strip that you're seeing here, it was like that. But then when I place it here on this aluminum heatsink, I got the idea to fit the size, the length here with the length of this aluminum heatsink that I'm having here, not to leave it too longer than this. In the idea that sometime in the future I will make a box probably, and I will fit. So I had to refit everything. I had to take it out from where I initially placed it, and change the position a little bit higher here. So these are more higher than it was before there. And in the same time I shortened the space here. So now I cannot put a larger resistor, but this was the design of it. This was the idea here, to actually add those very big resistors in case I will need them. The hardest part for this project, for this circuit that I'm having here, was to figure out where to stop. What do I actually need and where to stop? I have three variables for this circuit. I have, let me actually show you the actual circuit. So I stopped with this design. I didn't pursue it because I explained already why. Or although I I already started to make it here, the interface like a face, like a user interface, but nah, I give up on it. So this is the actual circuit that I'm having right now here, that I was thinking to implement it in that second version that I built it here. This is the second version that I'm having here. So with two resistors, these two resistors, I noted it here. This what I'm having here is this guy 5.6 ohms at 2 watts. Probably is 2 watts. I'm not completely sure what wattage is this specific resistor because it is scrapped from somewhere, and it looks like a 2 or 3 maybe, or 2.5, who knows. But I put it as a 2 watts because the power that I'm running everything is at 2 watts actually. And here is this 1 ohm 5 watts that you are seeing here. And as you can see, it's having a long leg here that is actually not connected to anything. You see, if you can see, it is dangling in the air, you see. And if I'm pressing it, it's no problem if I'm touching those wires. I will not get electrocuted. To give it a little bit of juice. Right now everything is running through this resistor, exactly 5 volts with 007 in this case, because I moved a little bit the potentiometer. But when I'm touching that, when I'm connecting this, is bypassing this resistor. This 5 ohm is bypassed by this 1 ohm. So if I'm touching it like this, so it is running right now through the 5 ohms. It's 0.07, and now when I'm bypassing it, is 0.3. So that's the role of this 1 ohm 5 watts resistor, is bypassing it quite quickly. Very good for experimenting. And if I need it specifically for higher wattage, I will solder that leg instead of leaving it as it is right now, like a switch. Pretty much is like that. Is performing the role of a switch. This leg that is barely visible, but is here. You see, when I'm pressing it like this, it's touching there. So I've added this LED with 300 ohm resistor because the LED is an old style of LED. It's not pink. In the video, it's looking like it's pink, but in reality, it's very, very strong red, and it's very beautiful strong red actually when you look at it from this point. And it's a bit weak. It's not a new LED. It's a scrapped LED from somewhere. Now, what I've added more stuff to it, but probably that's it. Oh, well, yes, this wire, it was connected here, I believe, if I remember right, originally. And from here was very thick wire to there. And so now I rewired a little bit better by adding this smaller wire that is, it doesn't need to be thick. This wire is only for the chip itself. That's it. And I had to build it a couple of times. Actually, this is the cardboard. The original cardboard size is from here to here, but this little, you see, is an add-on of cardboard. It was a longer cardboard, like I said, and I glued a piece of paper here and underneath it. So one on top, one on the bottom, and I make it larger, this cardboard size, you know. And now it's fitting this radiator that I'm having here. Why I needed it a little bit more larger is for these resistors to stay. To have this variation of resistors. And getting back to my original idea, when I mentioned I'm having 3 variables. One of those variables is this resistors that I'm having here. They are I have to change them accordingly to my needs. Then the other variable is the actual transistor for testing, but right now in this module that I'm having right now here is not for testing anymore, is only driving that transistor specifically. And now I put a cross on it, and that's it. This is a fixed transistor, is not a testing. I'm not testing transistors anymore in this place with this circuit. Theoretically, I can test other transistors, but for that I have to take out these wires to uncouple this transistor that I'm having here, to take out these wires that are going to it, and put other wires to the new transistor that I want to test. So this is a second variable that I had to keep in mind, and that's why I liked the original idea of this board. That is very extremely flexible, and I'm having access. I can actually get my solder, my iron, and solder visibly and without making mistakes, of shorting or anything else directly. And it's very visible, very, very clear right now, here. So that's for testing a transistor. And next, the third variable, so number 3 variable, is to actually add other components and test them through this fixed transistor that I'm having it already mounted here and linked and everything that you're seeing here. So this is the most deceiving simple circuit I ever met. Is looking extremely simple, but it is having these 3 great and bigger variables that I had to keep in mind, and I was struggling with them for a couple of days, even weeks, probably 2 weeks that I'm building this thing, and I was keeping an eye on, and I'm not completely happy with what I'm having here as it is, but it's good enough for the function, is doing the function. Now let me show you a little bit. Yes, another point I wanted to add here with this circuit, the new arrangement that I was having here is that I was putting actually I was thinking on a suggestion from my friend to add this power wire here, or this clip directly here on the collector without this thicker wire here. So that was the idea of remaking, that was one of the idea of remaking the entire circuit, because of this point here, to add the positive directly on the collector of the transistor, very close to the collector of the transistor pretty much. But it's not a good idea, because I will have negative here wire, so negative wire is here and the positive wire is here, and I will have this kind of wiring arrangement, while the way I'm having it right now here, as you can see, is on one side, and I really much like it as it is in one side. Even if I had to add this very thick wire here, well, I remodeled everything around it, and I clean it up right now as it is. So that's another issue, design issue I was fighting with. I will not discuss about what this represents here, this and this. I was for this very quickly, I was thinking to, as you can see here, I was having this jumper here, and I was thinking to add a jumper. You see 1 2 3, and is these 3 pins here, 1 2 3 pins, and I was moving this jumper from this 2 to this other 2. Pretty much that was the idea. And in one side I was having 2 watts, and on the other side I was having the 10 watts. But I resolved this issue with doing this, or soldering for good this leg of the resistor to that longer pad that I'm having there, or track. So that's what I'm having there. And here there is a very big problem. Well, it was a very big problem until I find a solution. The problem was, in the original circuit I was following specifically this, my friend, values he used, and he used this 0.2 ohms, and I was having exactly this resistor. You can see it is having the solder on it, and I was having it here instead of these 2 resistors. And because I was having this very low resistance here, the potentiometer, when I was moving this potentiometer a tiny little bit like this, it was jumping a couple of hundreds of milliamps. So when I was moving the potentiometer, these milliamps were jumping like crazy. You see, like not as smooth. You see how smooth is running right now? It's like a beautiful girl eyes rolling back and forward. You see, it's very easy and very intuitive to move it like this. But before, when I was moving it from here to here, it was jumping a couple of hundreds of milliamps, like 500 or 800 milliamps, and it was a pain in the butt to obtain this resolution, this very fine adjustment that I'm having right now. And you see, I'm having a quite good delay between you see 19 and 18. I'm actually moving it quite a lot, a little bit, so I'm having a very good resolution between 2 numbers. So the idea is that resistor was bad for the circuit that I'm dealing here. It was good as the beginning circuit, but not adapted to what I'm having here. So I started to adapt my resistors here, and by adapting them, these 2, I solved this problem, this very important problem with the potentiometer jumping too fast from one value to the other. So now I'm having a very smooth transition. Okay, now let me present to you the total travel of this potentiometer and its maximum wattage that I'm getting from it. So right now it's coupled all the time. This resistor, this 5.6 ohm resistor at 2 watts, this round one, is connected all the time. Remember, this is only bypassing this one because it's lower resistor than this. This is 1 ohm, this is 5 ohm, and the current likes to go where is easy to travel. So if I'm touching here, it will go through, it will choose this less resistance than this one to travel through this. So that's why this is bypassing it successfully. That's my idea that I used here. So now when it's not connected, this one is not connected to anything. I know it's not showing very well, but it is not. This is staying in air. So now I'm having connected only this 5.6 ohms here. So now I'm at 0 here, and I will move it to the maximum there. And now I'm looking here at the amperage, and I'm seeing 0.4, the maximum. So you see, this is the travel is at its maximum. I cannot move it further than that. It's from one maximum, from one end to another end, pretty much. So I will have to bring it back to a minimum, because this is the problem. This is a very big problem I will have to keep in mind, and I will have to make a note somewhere. If I'm leaving it at the maximum, or somewhere in the middle, probably it will jump. If I'm connecting this resistor, which is lower ohms, it will jump to the maximum wattage. But now it's a bit safer, because when I was having this 0.2 ohms, it was jumping to, I don't know, I never tested, but it was very, very jumpy. It was jumpy to 50 watts or something like, or 100 watts probably. And it was for sure, it was being able to burn the transistor that I'm having it there. So that was the problem with that very small value that I was having. So now it's a bit more calibrated, even for the maximum. If I'm switching the resistors here, when this potentiometer is at maximum or close to its maximum, it will not be that much of a problem of jumping to a too much higher wattage. Although it's a big jump from 2 watts to 8 watts. So I was having here, so right now I'm having, because right now is at maximum here, and I'm having 5 volts with 0.4, and this means exactly 2 watts. Let me show you. So 5 volts times 0.4 equal exactly 2. You see, exactly 2 watts. Good. So that's why I choose this lower wattage resistor, that it is terribly hot right now when it's running at its maximum, and I can probably smell it a little bit when it's running at its maximum wattage. Probably, I'm not completely sure, maybe it's 1.5 watts, but it's for sure is a little bit bigger than 50 degrees Celsius there, or it's very hot. So I will not let it run at that temperature, because this is getting extremely hot, this little one. But if it's lower than its maximum, is pretty cold. It's running pretty cold, so it's good enough. It's good enough what I'm having here. Next is this guy, and I'm not sure how I can film it and press there and move this potentiometer and show you the. I hope I can do it with one hand without electrocuting myself too much. So now I'm bypassing by connecting this leg there, and I already have 1.59. But I will do this. I'll move it to the maximum, and when I will touch there, you see 1.75 actually I got at one point. Probably it was a little bit more hot. Something was hot. Yeah, it will increase for sure. It will increase. I know from experience now. So 5 volts, 172. And now I'll bring it down to a lower value. So let's see the calculation, what this is telling me. So 5 volts times 1.72 equal 8.6 watts. And I'm totally happy with these values. Actually, I will have to write them down here. So I write it here. Although this resistor, it might be actually at 2 watts. But in the same time is the maximum that this circuit is running with this resistor connected here. And this one, it will give me 8.5 watts when it's connected there. So I'm having these two values, and also is resolving the traveling issue for this potentiometer in the same time. Although for this resistor, it will jump a little bit more higher in values. It will not be smooth as this one. But if I will need more coarse values, I will use this. More power. If I need more power, I will use this. And if I need something more not that powerful to test, I will leave it connected to this one. That's the idea. The design of the entire circuit is very cool. I like it. It's looking like a freaking bomb. But this is the thing. And next I plan, and I really want to test a voltage regulator with a couple of aluminum heatsinks, with this heatsink and some other scrapped aluminum heatsink that I'm having. Unfortunately, these are fixed here. These heatsinks are fixed, and it will remain fixed like this forever from now on. I made my mind, or better said, I made my peace with how much wattage I want from this device to test, and the values that I'm using, what transistor to use. So I'm pretty tired of this circuit to test it, and now I made my mind. This is a fixed and a total fixed circuit what I'm having here, but also with the options open to change either these resistors, either the transistor to take it out, this fixed one that I'm having right now, to take it out, to uncouple it from here and test other transistors with other heatsinks probably. And next to add another component like my this voltage regulator that I'm planning next to add it here, and finally start to test it properly, because now in this moment right now I'm having a proper circuit to test something else at a reasonable power at 8 watts is good enough, I believe, in my book, as a variable load tester that I'm having here. This is the role of this entire big brick to variate a load pretty much. And it's pretty cool. It's pretty cool. I really love the circuit. I really love it. That's why I spent so much time on it, to make it as hackable as possible. And for that, I had to change it many times, like more than 10 times. I changed the entire circuit position, and fucking shit. And also the transistor, I test the shit out of them. Yeah, it's quite an interesting circuit. I really like it, and I really suggesting for other electronists or someone that wants to learn a little bit of electronics to actually do it. And I personally learned a lot about heat sinks, a lot about thermic or temperature radiation in aluminum, specifically in aluminum, how much aluminum you must add to dissipate a good amount of energy of heat. And what I'm having here is not enough, and I know it, but it's good enough, everything to a certain limited level. That's the idea, you know. And yeah, it's very hackable circuit what I'm having here. That was the idea. All right. Also another subject. So the subject about this circuit is closed right now. Let me discuss about something else, about this motherfucker transistors that I'm having here. My friend from America, my friend from UK, England, they both suggested me to open one transistor and to check its internals. And I said maybe later, maybe sometimes in the future. I wasn't very fast to cut one very quickly. But yesterday I was talking with my friend from Romania, a distinguished professor, engineer, and military decorated and veteran, Mr. Kiro. Mr. Kiro is an old friend of mine. We know each other from adolescence. And he is actually an audio electronics, as the entire country, all the electronics here in Romania are into audio. And he also suggested me, after showing him these transistors and telling him this is the most powerful that I'm having, the 150 watts, and he said, this is nothing, 150 watts is nothing. And I asked him, how much did you use in your life? And he said 100 watts. And this is nothing. Okay, so but the idea is that he also suggested me cut the fuck one and see the fuck what is inside, if it's that very small little point of silicon die, or if it's a larger die, like a normal transistor should have. And here it is. Let me bend it back like that, because I leave it a little bit there to be bended until it will get off completely. So let me actually zoom in. I made some pictures as well, but probably it's better to actually zoom into it. Yeah. And I have a couple of ideas to tell you about a little bit of experimentation that I did with this transistor, and I realized it's is not deserving 10 stars, is deserving 5 stars. 5 from 10. So it's 50-50 pretty much. Is 50 good, 50 bad. Because first of all, my American friend is insisting that other companies are making, this is a well-known thing that they are making from steel, this case. So I was expecting, I swear to God, I was expecting this entire case to be from copper or aluminum, at least aluminum. I was sincerely expecting this will be copper. And I did the first test that I did this before I cut it open. Let me actually zoom in. So I took a file and I file it. You see there is steel all day long. That's the color of steel. That's not the color of aluminum in any universe. So that's the first test that I did. I file it there. And then I got the idea, let me do the magnet test. So what I did next, I did this. I have this small magnet. As you can see here on aluminum, is not doing shit. You see, it's not catching on it. Don't run away. But here, on this thing, you see, it is catching. And you see, and it shouldn't. It fucking shouldn't. You see, it is definitely, this is steel. And another problem, and my Romanian friend said to me that his cases were from brass. And my American friend said, well, steel and aluminum sometimes. And my Romanian friend said from brass or from aluminum, what he saw in his life, you know. And I hope I didn't fuck it up inside. And next, I did, after I opened it up and I looked inside, I made, here it is. I tested the leg. And I said, well, maybe this is steel, but the leg should be copper, like every other component, no? And check this out. It's also steel. And this is shit. This is shit. That's why these very cheap transistors are so cheap, because they are using steel instead of copper or aluminum. That's the problem. And also I'm making the magnet test on the leg itself, like this, you see? It is holding on the legs. It is holding. And if I'm doing this, almost is running out. So these legs should be from copper as well, and they are not. And they are making a shit connection inside. They are making an absolutely shit connection. Next item is, so now I will take this away. And the next thing are these wires. My friend from Romania, Mr. Kiro, said that these two wires, they are called bonding wires. are made from indium, but in his opinion, this indium material is not used in these cheap transistors. And then I read on the internet, and the internet is saying that they are made either from aluminum, either from gold, or either from copper. But this is neither. Is nothing. I tried to file it. It's not elastic. It's actually plastic. When I press it very extremely lightly, I don't want. I was scared actually how easy they were bending, and they were retaining the shape of the bending. I cannot show you. Yeah, probably like that. You see how it is remaining in the bent position. Yeah, see, it's like a plumb in my language, plumb. I don't know in English. It's like a very soft metal here, very extremely soft, and it's very strange metal that is using here. It's not steel, so this is a good news that they didn't use steel here. But I'm not sure about indium. I never put my hands on indium. I hope they are in indium. But this is a very strange material, very strange wire, bonding wire. And my American friends said that this bonding wire should have been more thicker than what I'm having here. But my impression is that the material they are made of, these wires, probably they confer a little bit of more power resistivity to, like 16 amperes. This is made to work as to transmit 16 amperes through these wires. Probably one is the base and one is the emitter. So from this case, through this emitter, probably that's the current flowing, and one of these wires should actually be able to support those 16 amperes. I pretty much doubt it. I don't know what size is. Let me actually measure it. So it's 0 here, 0.5 here, and that's the diameter of this internal bonding wire that is having there. Last night I was thinking of this transistor, how to make it better than it is right now, to eliminate all this steel problem that is having, and I was thinking to reshape it, to remodel it, to extract this transistor die that is having there and mounted it on a copper surface instead of this steel surface that is having here, and make my own copper legs. Pretty much that was the idea that I was thinking, but I'm not sure if I will be that kind of crazy to get through until there. So far what I'm having, I will deal with what I'm having, and whatever the power I'm having from these ones is good enough, I suppose. But they are definitely better than my BD 681, because when I test in the air without any heatsink, my BD 681 got to 350 milliwatts, yeah, and this got to 1 watt in air alone without any heatsink, up to 50 degrees Celsius. And that's the thing. They are definitely better than my BD 681 by themselves, and most probably with a proper heatsink as well. So I will use them as they are, as I get them. And if I would get into the crazy mode and actually modify the entire structure that is having here to put it on a copper, I will think about it. That will be extremely challenging to do. I already find some solutions how to do it with a very limited tools that I'm having, and yeah, I will see. But until then, this was the subject that I wanted to discuss about it. And also these transistors, these very powerful transistors are like I said, they can be powered to 150 watts. But my power supply that I'm having there, adjustable DC power supply, see, is 30 volts maximum on 5 amps. So 30 times 5, it means 150 watts exactly. But I will never bring it on that kind of maximum power, because I really love my power source. Although I have this other one that is more capable probably than this one. I'm not completely sure, but I don't want to push them to too much power. I mean, probably the maximum power that I can push from this power supply, probably it will be 100 watts, maybe. But I doubt I can, maybe 50 watts, because at around 10 watts or so, it is starting to blow air. Seriously, it's having a fan on the back. It's blowing air, and I can hear it like a zzz. And at 50 watts, hopefully it will not blow up. But it's a problem. I have a problem of power supply. That's another completely separate issue and discussion, and I will not go there. This circuit that I'm having here so far, it should be enough to test other transistors, other voltage regulators, and other heatsinks in combination with those components, pretty much. And it's a very good thing to have, to actually test the heatsink and the component, and how big your heatsink should be for your component at what wattage. And at 8 watts that I'm having here, I will be super happy. And for a very short amount of time, I can add another lower than 1 ohm resistor, like 500 milliohms, so 0.5 ohms, and test it at even higher wattage if I really need it, something that powerful to run at. But that's the beauty of this thing of my contraption that I'm having here that is extremely hackable. I can take out this and put whatever I need and then put this back when I finished with that, and that was the project. And that's why it took me so long. And it took me quite a long time to actually find the solution. And I'm not completely happy with how it's looking, but doesn't matter because it's looking like a bomb. But it doesn't matter. If someone will catch me with this in my bag at an airport or in a naval port, you know, with ships on a sea, they will send me directly to the gulag in Russia. All right, so that's it for this episode and for this subject, and I hope you learned something how big shit must be, and that's the entire idea of me presenting how big shit can be, must be. All right, thank you very much for watching, thank you very much for listening, and I hope you like it, and see you later with other updates and other cool experiments from your favorite artist electronist, Mr. Q12. Bye bye.